Real number exponents. Real number exponents include rational exponents, which we just did, and irrational exponents. Now, irrational exponents would be such as square root 3, pi, 3 square root 2, anything like that. Those are all irrational numbers. And those are the exponents that we're going to be looking at today. Nice pretty shade of yellow for our definition. Okay. Now, we went over rules of exponents, so they're the same rules of exponents. Same rules of exponents. Okay, so you're just using the same rules, and I know that those are, those in blue. Okay, same rules of exponents that we've always been using. So let's look at an example. And this example is going to be an example where you're supposed to multiply. Okay, so here's multiply. 2 to the 4 minus square root 5 times 2 to the 1 plus square root 5. So I'm multiplying, and remember, it's the same rules of exponents. So when I'm going to multiply bases, I don't really multiply the bases. I just do what? Oh yeah, I just add the exponents. So it's going to be 2 to the 4 minus square root 5 plus 1 plus square root 5. 4 plus 1 is 5. I have square root 5 plus square root, I have negative square root 5 right here. Negative square root 5 plus square root 5, and that gives me 0, so I don't need to use it. What I end up with is 2 to the 5th, or 2 to the 5th is really 32. Okay, same rules. We're doing nothing different. It's just now you have to deal with radicals. Okay, here's another, let's do an example of, let's go from a power raised to a power. So here's an example. A power raised to a power. Power raised to a power, this example. So I have 5 to the 2 square root 3, all raised to the square root 3. And remember, it's the same rules. So when you go from a power to another power, you're going from a power raised to a power. What you're going to do is multiply. So what I'm going to end up here with is 5 to the 2 square root 3 times square root 3. Or 5 to the, multiply the outside numbers together. 2 times 1 is 2. Multiply the radicals together. Square root 3 times square root 3 is square root 9. Square root of 9 is 3. Or 5 to the 6th and 5 to the 6th, we would have to get out our calculator and figure out that it's 15,625. 15,625. Okay, so you're going from a power to another power. We're going to multiply. I went ahead and simplified, multiplied, and then I used my calculator to get that number. So that's an example of a power raised to a power. And you can work down. I worked across because I was kind of running out of room. So you can go ahead and work down like I worked down this way. Sometimes that works a little bit better. But for me on these notes, I kind of ran out of room, so I went sideways. Up to you. I will try to work down. Okay, next. Next we still have our real number exponents. And this time what we're going to do is we are going to do an example with a quotient, and that should hit, oh, then we'll do one with everything, I think, and then that should be it for examples of this process, and I'll show you one more. So this is with a quotient. Okay, so when you're doing your work, really you just need to look at these and follow them. That's all you're doing here. So here's my example of quotient. I'm trying to just prove to you that it's the same rules that we've been using before. If you don't know the rules, then you're going to have to learn those rules. But we went over them in class again too. So okay, so there's a quotient, and we know, because we did go over them in class again, that when we're going to do a quotient, what we're going to do is we're going to just subtract the bottom from the top, right? So we're just going to go ahead and use the 3, the base, and it's going to be 2 plus square root 7 minus, and you're going to have to use parentheses. So that's a don't forget, okay? Don't forget to use parentheses here. That's pretty important. And I'm going to do it in red pen, except I have none. Oh, okay. Well, I don't know where my red pen went, so how about pink? Pretty shade of pink here. Don't forget parentheses. Okay. All right, so what we're going to have then is 3 to the 2 plus square root 7 minus 2 plus square root 7. And we're going to look at that, and we're going to combine like terms. Here's my like terms, my 2 and my negative 2, and my square root 7 and my square root 7. What I'll have then is 3 to the, I have a 2 and a negative 2, so that's going to go to 0. I have a square root of 7 plus square root 7. Square root 7 plus square root 7 is, well, you know what I do? I have 2 square root 7, so 2 square root 7. Sometimes they show it like this and leave it like that. Sometimes, though, they'll go ahead and take the 2 and raise the base to the second power, or whatever number they have outside the radical sign. So it could look like this. It could look like that. Okay, so one of these two. So there's two possibilities here. Two possible forms. Not answers, but just two possible forms. Okay, not sure. And I think this book kind of goes back and forth with them. I'm not really sure. So there you go. So an example of quotient. All right. If you need a second, go ahead and pause the video. You can take the rest of those notes. I'm gonna start on something else here. Something that's new. Oh, no. I take that back. I forgot. I was supposed to do an example with multiple steps. Let's do that. I can squeeze that in this one. We'll do an example, multiple steps. Multiple, I want to say multiple steps. Yeah, I guess. I'll just say that. Okay, so this just combines a few things here. Combines everything you know. So what we want to have is this. 6 square root 12 times 6 square root 27 all over 6 square root 3. Okay, now, so this one has a few steps to it. So we have a radical 12, or I'm sorry, a square root 12. So square root 12 is square root 4 times square root 3. Square root 4 is 2. So I would have 6, 2 square root 3. 27 is 3 cubed. So, or square root 9 times 3. So what I'd have is 6, 3 square root 3. And then on the bottom, I'm going to have 6 square root 3. Okay, so I simplified my radicals and I rewrote it. From here, what I'm going to do is I'm going to go ahead and I'm going to combine these. And this was the first one where I said where we're multiplying. Well, we don't really multiply the bases. All we have to do is add the exponents. So I have 2 square root 3's, 3 square root 3's. That means I must have 5 square root 3's all over 6 square root 3. When I have a quotient like this, just like I did up here, all I'm going to do is subtract the bottom from the top. So what I have here, I'm just going to pop down right here. I have 6, base 6, to the 5 square root 3 minus square root 3, which is going to give me 6 to the 4 square root 3. Okay, and then that's going to be my answer. Sometimes in the book they'll go 6 to the 4th. I would need my calculator, which I do not have handy with me right now. Okay, so I'm just going to leave it like that. Okay, so could get to be where there's, you know, a bunch of steps that you're going to have to do. So I showed you the basics, and then I showed you how to put it all together. Okay, pause your video if you need to, and take the rest of those notes. So we're still looking at real number exponents. Okay, now these are super important because this is something that we're going to use when we're solving for logs. Okay, so this is the base for solving logs. So we need to really pay attention here. Here is this is called solving exponential equations. Exponential, that's what that says, equations. And they would look like this. 4 to the 2x equals 1/2. To the 1 minus 2x. Okay, now, when you're solving exponential equations, what I'm going to show you in class too, is that you're going to be looking at where the x is. So this type of problem is x is the exponent. X is in the exponent. And I want you to write that down because that's the big deal here. I'm going to show you that you have to locate x, and when depending on if it's the base or the exponent or just on the other side, you're going to solve them differently. So everything gets solved differently, so you have to know where x is. So x in the exponent. X in the exponent. I have a frog outside my window and he's super loud. Can you hear him? Okay. So anyway, the first thing you have to do, so number one is, I'm going to use this color instead. Number one is you have to match bases. And right now my bases don't match. So what I'm going to do is I'm just going to draw around this guy right here. And this is what I'm going to look at. I'm looking at that, and I'm looking at this. And I'm going to draw myself another little box right here. And I'm going to put the same exponents that I have right now to the 2x, to the 1 minus 2x. Okay, now I have to match this base with this base. But they don't match because one's a 4 and one's a 2, or 1/2 actually. But I think what I could do is I could write both these in base 2. So if I take the 4 and write it in a base 2, it would be 2 squared. Do you agree? 2 squared is 4. If I look at this 1/2, really what that is 2 to the negative first power. Okay, well, I'm going to draw in some parentheses here. And I'm going to go ahead and say it's, and I'm going to simplify because I'm going from a power to another power. So my next step is simplify. And maybe you can, maybe you can't. This one you can. Okay, so I'm going to go 2 times 2x. So I have 2 to the 2 times 2x, or 2 to the 4x. Over here what I have is 2 to the negative 1 times that quantity. Or 2 to the 4x equals 2 to the, I'm going to distribute the negative 1, so negative 1 plus 2x. Okay, now, their bases match. The 2 and the 2 match. Once the bases match, then you can write a new equation. And the new equation is just using the exponents, because 2 to the 4x has to equal 2 to the negative 1 plus 2x. So don't these two then, let me draw a little circle around, don't these two then by default have to be equal? Wouldn't this have to be equal to this to make this a true statement? They would have to be equal. So for example, if I had 2 squared equals 2 to something, what would it have to be? 2 squared? Well, wouldn't it have to be 2 squared? Or if I had 2 cubed equals 2 to the something, well, wouldn't this something right here have to be 3 to make it equal? Wouldn't it? All right, well, what I'm going to do is, and I'm going to draw those fancy little boxes around again. Around this, My boxes are going to be right here. I have my equal sign. I have my 3x. I have my x minus 1. None of that changed. That's all still the same. So I'm going to be looking in this green box. I'm going to be looking in that green box, and I'm going to see how can I match my bases. Well, I think that I can have the base be 5 on both of these. So this one I don't have to do anything with. It's already 5, right? This one I'm going to have to change. 1 over 25. 1 over 25 is 1 over 5 squared, but that's not good enough. I need the 5 in the numerator, so it would be 5 to the negative second. Okay, so 1 over 25 is 5 to the negative second, right? Now I need to simplify. So this, there's nothing I need to do with it. This, I'm going to have 5 to the negative 2 times x minus 1. My bases are matched. I can write a new equation just with my exponents, okay? Because this has to be true, right? Again, if I had 5 squared equals 5 to the what? Well, it would have to be 2 because that's the only way that it would be equal, right? These have to be equal if my bases are the same. So I'm going to write my new equation. There's my new equation. And now all I have to do is solve for x. So I have 3x equals negative 2x plus 2, right? And distributing the 2. I'm going to add 2x to both sides. And I have 5x equals 2, or x equals 2 fifths. So 2 fifths is my solution for x. Just like that. Okay, so these are x in the exponent. And in our notes, we are going to get all of these straightened out so we know what we're looking for. That's the end of these notes, and we'll talk more about this in class. See you tomorrow.